Welcome back. Today we're going to learn about one of the most important data structures in programming, the hash table, also known as hash map. So what exactly is a hash table? Imagine you have a huge library with thousands of books. Now, instead of searching shelf by shelf, what if someone just told you, go to row 5, position 3, and your book is right there? That's exactly what a hash table does for your data. It stores data in key value pairs. You give it a key, and it gives you the value, almost instantly. But how does it know where to store things? This is where the hash function comes in. Let me break it down step by step. Let's say you want to store the key apple with value 5. First, the hash function takes the key apple and converts it into a number. It does this by adding up the ASCII values of each character. Then we take that number and apply modulo with the table size. The result? An index number. And that's exactly where our data gets stored. So the formula looks like this. Index equals hash of key modulo table size. Simple, right? Now here's the interesting part. What happens when two different keys produce the same index? Like what if apple and apricot both land on index 3? This is called a collision, and every hash table needs a way to handle it. The most common method is called chaining. In this approach, each slot in the table holds a linked list. So when a collision happens, the new entry just gets added to the chain at that index. Easy and effective. There's another method called open addressing, where we look for the next available slot. But chaining is more commonly used and simpler to understand. Now let's talk about performance. On average, hash tables give you O of 1 time complexity. That's constant time for insert, search, and delete operations. This makes them incredibly fast. But in the worst case, when all keys collide into the same bucket, it can go up to O of n. That's why choosing a good hash function matters. You also want to keep an eye on something called the load factor. It's the ratio of entries to table size. A good rule is to keep it below 0.75 to maintain performance. So where are hash tables used in the real world? Honestly, everywhere. Databases use them for fast indexing. Caching systems like Redis and Memcached are built on hash tables. When you log into a website, your password is verified using hashing. Compilers store variable names in symbol tables, which are hash tables. Even Python dictionaries, JavaScript objects, and Java hash maps, all of them use hash tables internally. So, to wrap it up, a hash table is a key value storage system that uses a hash function to compute where data should live. It handles collisions through chaining or open addressing, and it gives you blazing fast O of 1 access time on average. If you want the best animated tutorials on data structures and algorithms, head over to algopoc.com. We make complex topics simple and visual. Thanks for watching, and I'll see you in the next one.